Hello students. In our day-to-day life, we perform various kind of activities. For example, as we read books, when we are going for a walk, there are varieties of activities that we are involved with in our day-to-day life. The way we visualize work in our day-to-day life and the way we visualize work through science or in the concept of physics is basically different. You are singing a song. For that, you may say that you are doing some work. Or when you are kicking a football, at that time also you are doing some work. But in common man's language, we can say that we are doing some work. But if you look in the concept of physics, when you are singing a song, you are not doing any work. But when you are kicking a football, you are doing certain work on that football. Why is it so? Why in physics we term certain things that we are doing some work, but in certain situation we say that we are not doing some work. So to understand this, we will have a look at a short video that will help us to understand when we are doing work and when we are not doing work. What are the conditions that are required to say that some work has been done? So just have a look at that video.
The engine of the truck failed on the mid of the road. Now the driver need to move the truck to the side of the road. He is pushing the truck and trying very hard to move it but couldn't move it. He got help from another person passing by the road, but even after trying hard, he too could not move the truck. As both of them couldn't move the truck, what do you think? Have they done any work or not? We will find it out. After some time, they got help from two other persons. They moved the truck to the side of the road. What do you think now? Did they do some work while moving the truck? Let's find it out.
So what did you observe in that video? Initially, two persons were trying to move that truck and they were trying to give a push to that truck. They were trying very hard. That means they worked very hard to push that truck, to move that truck, but the truck did not move. Is that mean they have not done any work? In fact, very surprisingly, physics says that they have not done any work. Why is it so? It says, although you have applied certain kind of force on that, you tried to do some work, that by giving a push, but as the object, that means the truck did not move from its place, it did not change its position, that means you have not done any work. That means physics says whenever you are trying to do work, that means the force that you are applying must bring some change in the position of that object. There must be some kind of displacement in that object. If there is no displacement in the object, that means no work has been done. How much hard you must have tried, how much hard you must have worked. We may say that we have worked, but physics says that you have not done any work until and unless the force that you have applied has brought some kind of change. That's why in that video, initially when the two persons were trying to push, they have done no work, whereas in the later part of that video, when you watched, four persons, when they tried to push that truck and the truck moved, at that situation we can say they have done some kind of work. That's why Even if you are sitting in your room studying for several hours and you are getting exhausted, at that situation also physics says that you have not done any work although you have got exhausted. Until and unless there is a displacement, we cannot say that work has been done. Now I guess you are clear somehow when we can say that work has been done and when we can say work has not been done. So basically these two conditions are need to be satisfied in order to say that work has been done. And what are these two conditions? It says a force should act on an object and the object must be displaced. Both the conditions should be satisfied. That means we must apply some kind of force and that force should produce some kind of displacement in that object. Then only we can say that some work has been done. Now let's try to express work done in mathematical way. So before that, let's have a look at some situation whether we can say work has been done or not. Look at the first picture. Here the weightlifter has lifted the barbells over his head. Has any work been done? What you would say? Whether some work has been done, yes or no? If you try to correlate from the conditions that is required for work to be done, one, force has to be applied. Second, it has to produce some kind of displacement. So here we can see as the weightlifter has lifted that barbells, that means the barbells has moved certain distance, there is a displacement we can say, and he has applied certain kind of force, some amount of force. That means we can say in this situation work has been done. Now another situation in front of you. A person is pushing a wall but the wall does not move. Has any work been done? So here the person is trying very hard in order to push that wall, but we know that wall will never move. So can we say that work has been done? The answer is no. There is no work has been done because the force applied on the wall has not produced any kind of displacement in the wall. Hence displacement is 0. So the work done is also 0. Another situation in front of you. Bulls are plowing the field. Is any work being done here? Answer is yes. As you can see, they are plowing the field. There is some kind of displacement as well as force has been applied. So in this situation also some work has been done. Now coming to the final example. A car is waiting at the traffic signal but its engine is running. Is any work done here? That means you must have faced this situation in your day-to-day life also. While you are waiting at the traffic signal, the engine of your vehicle is on, it's still running, but is any work done here? The answer is no. Why no? Because there is no displacement in the car when we are observing at that particular instance. Whatever force is applied, there is no work done because there is no displacement. So from all this example, I hope you have understood that in order to say that work has been done, both the condition has to be satisfied, that is force has to be applied and there has to be some kind of displacement produced in the object. Now let's represent this work done in mathematical expression. So the mathematical expression that can be written for work done is equal to the product of force and displacement. W is equal to Fs. F stands for the force, S stands for the displacement. And here, as we know, the SI unit of force is Newton and SI unit of your displacement is meter. So, the unit for work will be Newton meter, or we express it in terms of joule. So, the SI unit for work done is joule. Now, dear students, if you try to define or in under what situation we say work has been done, the definition will be work done by a force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. Work is only magnitude and no direction. So, here we can say work is a scalar quantity because it is only associated with the magnitude, it has no direction. So, whenever we are quantifying work, then it will have only the magnitude. Now, as I said, the SI unit of your work is joule. When can we say that the work done on an object or on an body is 1 joule? So, that can be defined as the amount of work done on any object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. So, we can say the amount of work done is 1 joule if we apply 1 Newton of force, and that 1 Newton of force produces a displacement of 1 meter along the direction of the force. The direction in which we are applying the force, if the object moves in that direction, the displacement produced is in that direction, then the work done is said to be 1 joule. So, we will solve a simple numerical over here in order to understand the mathematical expression that we use for work done. So, here is the question in front of you. A porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. So, how do we solve it? So, the displacement is given to us and the mass of the luggage is given to us. So, from the mass of the luggage, we can calculate the force because gravity is acting upon it. So, the acceleration due to gravity, if we multiply with the mass of that luggage, we can find out the force. So, first let us see how much is the amount of force acting on that luggage. So, have a look. So, here we can say the force will be is equal to mass into acceleration due to gravity, that is g. So, mass given to us is 15 kg multiplied by 10 meter per second square, that will give us a force of 150 Newton. The displacement given to us is 1.5 meter. So, the work done will be is equal to W will be is equal to F into S, product of force and displacement, which is equal to 150 Newton multiplied by 1.5 meter, and that will give us a value of 225 Newton meter, or we can say that is as 225 joule. So, from the numerical, what we conclude that in order to lift that luggage to a height of 1.5 meter from the ground, the porter has to do a work of 225 joule. So, here we discussed that work done when the displacement produced is along the direction of the force, along the line of action. So, how will you calculate if the direction of the displacement and the force is not the same? That means, if we are applying a force at an angle with the displacement, how can we calculate that work? So, in order to calculate that work, we will use this following mathematical equation. So, when the displacement and the force has a certain angle, in that case the force can be divided into two components. Along the x axis it can be divided as f cos theta, and along the y axis it can be divided into f sin theta, and the expression for your work will be W is equal to f s cos theta. That means the product of force, displacement and also the cos theta. Theta is here the angle between the force applied and the displacement produced. So, by using this equation we can find out the work done when the applied force is with at certain angle with the displacement. So, to understand this, we will have a look at a short video.
Work is done on an object whenever a force causes a displacement. When a block of wood is pushed, it will move from point A to point B. The object's displacement is referred to as work done. Positive work refers to the displacement of an object in the direction of the force. When work done is parallel to a surface, we use a simple equation. W is equal to Fs cos theta, where W is work, F is force, S is the displacement, and theta is the angle between the force and displacement. In the case of our wood block, the angle between force and displacement is 0. Let's consider a larger wood block pulled with a rope that's tied at one corner. In this case, the force is at an angle, and so the work done is at an angle. If the angle theta is acute or less than 90 degrees, cos theta will be positive, and so the work is considered positive. In the case of a ball falling to ground, gravitational forces push downward in the same direction of the displacement. The angle between force and displacement is 0, so the work is positive. Negative work refers to the displacement opposite the applied force. When we lift a ball, the force of gravity is pressing downwards, but the displacement is upwards. In this case, the work done by the gravitational force is negative. When we slide a wood block across a rough surface, the frictional force of the surface will act in the opposite direction to the displacement of the wood block. So, this work done is considered negative. In these examples, the angle between the force and displacement is greater than 90 degrees and in fact is 180 degrees. Hence, the work is negative. Zero work is when no work is being done. If we leave a ball on a table, work is not being done because neither the ball nor table is moving. If we place the ball on our hand and hold the ball without moving it in any direction, still no work is being done. However, if we move our hand horizontally with the ball, the force on our hand is applied in an upward direction, but the movement or displacement is horizontal. In this case, the angle theta is 90 degrees because the force is perpendicular to the displacement, so the work done is 0.
So, we can say work can be of three categories: zero work, positive work, negative work. So, whenever we say that work is positive, in that situation that we have seen that the displacement is along the direction of the force. What if the force and displacement are opposite to each other? in that situation, will the work be positive or it will be negative? Obviously, in this situation, if the force and the displacement are opposite to each other, the work done will be negative. So, when an moving object we apply certain kind of force, we are applying that force opposite to the direction of the motion. That means the displacement, the direction of the displacement of that object and the force applied are opposite to each other. So, here we will take force as negative with respect to the displacement. So, W will be is equal to minus F multiplied by the displacement. So, that will produce a negative work. In what situation can we say the work done is 0? As we know, the conditions required for work is force has to be applied and there has to be some kind of displacement. So, in a situation where the force applied is 0, for example, an object is at rest, as no force is applied on it, we can say that there is no work done on the object, that means it is 0 work. So, dear students, that's all how we can define about work or any situation that we came across in our day-to-day life where it involves work, and you can easily calculate the amount of work that has been done on any object. So, we will conclude today's session with a simple question. A person is carrying a heavy load and standing still. So, can we say that the person has done some work? What do you think? If you apply the concept of work, the person is standing still and the load is on his head. Although there is some kind of force, but there is no displacement. So, as there is no displacement, there is no work. So, we can say there is 0 work. So, dear students, let us take up another numerical related to the work done. So, the question is, a force of 7 Newton acts on an object. The displacement is say 8 meter in the direction of the force. Let us take it that the force acts on the object through the displacement. So, what is the work done in this case? So, we can easily solve it by applying the formula work is equal to force multiplied by the displacement. The amount of force is given to us, the displacement produced by the force is also provided to us. So, we will simply use that formula. W is equal to F S, F is given as 7 Newton multiplied by displacement produced is your 8 meter. So, 7 into 8, 56 Newton meter, or that is equal to 56 joule. So, it's a very simple numerical that you can solve. There are plenty of this type of numericals given in your NCERT textbook. Do solve all those numericals, that will help you to understand the concept in a much better way. The rest of the concept we will discuss in our next module. Till then, take care. Thank you.